right, ready? P stands for?
Phosphorus.
Al is?
Aluminum.
Mn?
Manganese.
Manganese, right? H?
Hydrogen.
Hydrogen. K is potassium. We already talked about that. All right, there's a sidebar about chemistry and the environment. And we're not going to talk too much about this except to just say that this is a pure element, right? Carbon can be found. Carbon is one of the few elements that you actually do find in pure forms in the environment. Meaning you can actually find chunks of carbon. Any of you ladies have any chunks of carbon on you today? I'm looking at your hands. Why am I looking at your hands? Looking for diamonds. Who's got a diamond? You got a diamond on your hand? You got one on your necklace?
A little one.
A little one? A little baby one?
A few little ones.
Diamonds are a pure form of carbon. If you look at a diamond under a microscope, it is clear, right? There's no color in it. Carbon doesn't have color by itself when it's in that form. Okay. But if you change the form of the carbon a little bit, you can make it gray or black looking. And how do you do that? You change it from being a certain type of solid to being a different type of solid. And a lot of you have this form of carbon on you today. Who's writing with a pencil? That is a form of carbon. You're writing with graphite. We don't use lead anymore to write with. It's toxic, right? We write with graphite. It is pure carbon as well. It has a little bit different chemistry than the diamond does, but those are two common forms of pure elements. It's hard to find any other pure element. You find lots of mixtures or combinations of elements, but not a whole lot of pure elements on them, okay? And this other one down here, it's called a buckyball. They don't exist in nature, and nanotubes don't exist in nature, but we can make them in the lab, and they have buckyballs are used for lubricants and all kinds of stuff. And nanotubes are, if you heard about carbon fibers, like if who plays golf or goes fishing? Nobody? You hear about carbon fibers in the rods, or if you ride a bike, you talk about carbon fiber composites and that kind of stuff. Baseball bats, softball bats, all use them now. Okay? They're carbon fibers. They're actually strings of carbon that are bonded together that make the things very strong. Now, these buckyballs were only discovered in the 80s, okay? I was already in college when these things were discovered. Somebody made one in the lab. These guys have been around a lot less. The nanotubes have been around less time than that. But they're now using all kinds of things for strength. So, also, mercury. We didn't talk about mercury here, have we? Have we ever talked about Alice in Wonderland here? We have. I mentioned it. Who knows about the Hatter in Alice in Wonderland? We did. He's crazy because he ate mercury. Mercury is you don't find mercury by itself, but who's ever seen mercury, liquid mercury? You see it in, sometimes with thermometers, not so much anymore, they've gotten away from it. You can also see it like in a thermostat in your house. If you have an older house, it'll have a mercury switch inside the thermometer if you ever have to replace it. You shouldn't throw that in the garbage. You should take it to a recycling place. Okay? Mercury is very toxic. If you ever want to learn about mercury poisoning, go and Google Bay of Minamata in Japan. What happened is there's a plant there's a bay, and there's a river that flows into it, right? Where there's some kind of industrial plant up at the top, and they use mercury in one of the processes, and they're dumping their waste into the river. What do you think happened to that mercury? It didn't settle on the bottom. What happened to it?
I ate the fish.
That's a better sneeze than yours was.
Whatever. The fish ate it, and then he ate the fish.
Didn't eat it. The fish, big fish eat little fish, little fish eat what? Who watches SpongeBob? Plankton. Phytoplankton use light, grow. Zooplankton eat phytoplankton. Small fish eat zooplankton. Big fish eat small fish. Right? And what happens with most things is that Every time you eat something, you don't turn into that. You only take part of that to use it in your system. But it turns out for things like mercury, they do what's called bioaccumulation. As they go up the food chain, the concentration actually goes up. That's why you're not supposed to eat very much like tuna, swordfish, shark, all that kind of stuff, because those things have high concentrations of heavy metals, particularly mercury, because the concentration increases. So the Bay of Minamata, they're dumping this mercury-laden waste into the water, and the fish were all toxic. And what do they eat a lot of in Japan? They eat a lot of fish. It's a primary source of protein, right? Particularly one village. And they start, all the babies that were being born were having weird birth defects and stuff. And other people were starting to get sick. And it turned out that the plant was responsible for that. And the tragedy of it is that they denied being responsible for a long time. Okay? And so, if you go and look it up, there's still people being born in that region with birth defects because of this. Yeah, it's pretty sad. Can lead to death, right? So, all right, the periodic table. That chart I passed out is called the periodic table. It is like a multi-tool for a chemist. It is the one tool that we don't live without. We can't do without. Some of us have it memorized. I do not, because I use it all the time. Okay? I know lots of it because I use it over and over, but not all of it. Okay? So, right now, it's up to 118, but you'll see that there's some spaces missing. Here, 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 and here, there are elements missing, right? That's because if you look right here, element 92, everything that is above element 92, so it has a higher number on it than 92, is man-made. It doesn't exist in nature. Okay? So we've made those artificially. We have ways to make them. Okay? Then there's some that we haven't made yet. There's holes in it. Okay? Does that make sense? Note that the numbers increase. We start with 1, and we go up to 118. There's no element 1.5. It goes 1, 2, 3. What are those numbers called? Those are called 1, 2, 3 in math class. What do you call 1, 2, 3, 4? They're whole numbers. They're integers, aren't they? Positive integers. So, on the periodic table, we can divide things into groups and periods. Groups are vertical. And if you look at your periodic table that I handed out, they're numbered up at the top. Periods are also numbered, and they're horizontal. Okay, so they go from left to right. The one I handed out is also numbered. Right now there are 7 periods, going from 1 to 7. Let's talk about what makes a group and what makes a period. What does it mean to be in a group? Anybody in here in any groups? Who's in a group? Everybody's in groups. You have a group of friends? Yeah? Why are they your friends? You have something in common, you have similar interests, you probably act a little bit alike. Not identical, right? Hopefully not identical, but a little bit alike, right? Okay? So that makes you in the same group. Same thing on the periodic table. Everything that's in a vertical group, they have similar behavior. Not identical, but similar. Now, why are they called periods going across? Do we know of anything else that's called a period? Come on, ladies. Do what?
Time periods.
Time periods. What about periodicals? What's a periodical? Something that comes periodically. What else comes periodically? Really, ladies? Y'all want to talk about it? Y'all embarrassed? Okay, we want to talk about it. Why is it called that? Because it occurs periodically, doesn't it? Once a month. For most of you. Some periodicals come weekly, right? Time magazines come every week. National Geographic comes once a month. Time magazine comes every week. Newspapers, periodical, comes every day, right? Why are they called periodicals?
Bills come every month.
Yeah, those are periodic too. I don't like
We
those.
couldn't find them periodically.
Because what does it mean to be a periodical?
Not always rains.
It just repeats, right? So the beginning, and then it changes a little bit, and then it comes back to be the same way every time. Is it exactly the same every month? There's new articles in that magazine, right? I'm trying to keep it G-rated. I'm trying. There's new articles in the magazine, right? Even one in every group, though. Right? Things change. But then you come back to the start, right? The trends are the same. It just repeats. So in a period, as we move across the periodic table, there's trends. And we're going to talk about what those trends are. Then we come back to the beginning, back to the same group. So if we start in group 1 with lithium and move across, that's one period. And things change, and then we come back to sodium. And now sodium acts like lithium, and then we move across and things change slightly. Okay? So things are recurring. Now, group numbers are written at the top. Now the group numbers that you see, the one I handed out has both systems for numbering the groups. They can be numbered 1 through 18. I don't like the 1 through 18 numbering. Number one, I didn't learn that when I first started taking chemistry. That's not how we did it. We had the ones that if you look on there, it says 1A, 2A. Then if you skip over here to boron, it's 3A, 4A, 5A with the Roman numerals. Y'all see those? That's how I will refer to the group numbers. So when I talk about group 6, I'm talking about oxygen's group. I am not talking about chromium's group. Okay? Everybody understands that? That's how I will use those numbers. I will use the A's and the B's, not the 1 through 18. Okay? And there will be a reason for that that will be evident later. Now, if you're in group 1 or 2, or group 3 through 8, so if you're looking up here at the periodic table I have in my hand, group 1 or 2, or 3 through 8, you are what is said to be a representative element. Okay? Some books call those the main group elements. They're the ones that we will talk about most of the time. Okay? If you're down here in the middle, you are a transition element. Okay? You're transitioning from group 2 to group 3. That's why you're called a transition element. Now these ones down at the bottom, they're not in the slides, the ones down at the bottom are often called intertransition elements. We won't hardly ever talk about those because they're not common, they're not used for very much. Okay? These ones down here at the bottom, they're called intertransition elements sometimes. So, you can define an element by the group number and period number. So, if you look at the one up here, the element defined by group 2, period number 4 is, where's the intersection of those two lines? Group 2, period 4 is calcium. Okay? So that'll tell you something about calcium, the fact it's in group 2. So calcium being in group 2, it behaves a little bit like magnesium and a little bit like strontium. All these guys kind of behave alike. The properties of the elements change as I go from here across. Okay? And then when I come back here, it repeats through period 5. Okay? We'll do some more like that. Now, some of the groups have special names. You will hear me talk about alkali metals or alkali earth metals. Or you may hear me talk about halogens. Or you may hear me talk about noble gases. Instead of using the group number, some of the groups have special names. So when I talk about halogens, I'm talking about group 7 or 17, right? The one that I gave you has these names on it at the top for the special names. Okay? The ones on the right are called noble gases. They're all gases at room temperature, and they're very unreactive. We won't talk much about them at all. We will talk a lot about alkali metals and alkali earth metals. These are the transition elements in the middle. These over here are part of the representative elements. See, these and all these are representative elements.